Hi everyone, this is going to be a video on thermoregulation, specifically looking at the limits of life that exist for the human body. So one key thing to remember in terms of temperatures here is that we're looking at internal temperature here. So let me first delineate what the difference is between external and internal temperature. So external temperature is the temperature in the external environment. And when we're talking about the limits for temperature in terms of the human body, it's usually seen that the human body can't survive when the external temperature is below 0 degrees Celsius, obviously, and above 45 degrees Celsius. And that's related to external temperature. But what we're going to be looking at here is your body's internal temperature. And basically there's a scale that exists and explains the limits for life that your body has. So let's start off firstly in the middle. So I hope you all know that the normal temperature for the human body is between 36.5 and 37.5 degrees Celsius. And that's a normal physiological temperature that we need. And the reason for that temperature being that specific range is because the proteins in our body can only operate at a specific temperature. So maintaining that temperature is very important. Otherwise, we risk those proteins either denaturing if the temperature gets too hot, or them slowing down to such an extent that they're basically non-functional if the temperature becomes too low. Now there's two key things that control this temperature, and they come under two specific areas. So one thing is the core temperature, and another is the shell temperature. Now the core temperature is something that remains the most constant throughout basically your entire day, and it's what's maintained deep within your body. So I'm talking all your abdominal organs, muscles, they're all managed under a core temperature, and this temperature doesn't really change that much. It usually just remains between 36.5 and 37.5 unless you have a fever, unless you're exercising, because during exercise your body temperature usually increases about 1 or 2 degrees. If you have a very high emotional response to something, then your temperature can increase about a degree. Your shell temperature, on the other hand, is the temperature that's present just below the level of your skin. And that temperature is highly, changes a lot. It can be between around 20 degrees Celsius to 40 degrees Celsius. So depending on the environment that you're in, your shell temperature can actually change a lot. And the shell temperature is key, usually because just below the skin, we have superficial veins. And these superficial veins are responsible for thermoregulation in that they allow for the exchange of heat between the external and internal environments. So when your superficial veins dilate, they're letting more heat out of the body. So if you've just come from a run, if you've just exercised, then your veins are very dilated. That's partly because your muscles are using a lot of energy and there's a lot of blood going back to the heart from the muscles. But at the same time, it's because these veins are trying to get rid of the heat that your muscles have generated to cool your body down. On the other hand, if you're in a cold scenario, maybe you're in the snow, then your veins, your superficial veins, constrict because they try to grab onto that heat as much as possible so that it isn't lost to the external environment. And that's one of the precipitating factors to frostbite. In frostbite, what happens is your veins constrict so much that your extremities don't receive enough blood, and that's what causes for your extremities to become blue or even gray in their discoloration. And that basically means that they can become black, so they can experience gangrene, and you could lose your fingers and toes because your veins have constricted so much, or even your arteries in this case, if you experience extreme cold temperatures, have constricted so much that those tissues aren't receiving enough energy, enough oxygen, and they undergo ischemia, where they just die, basically. Now, you may be wondering, these core and shell temperatures, they must be regulating each other in some manner, and you're absolutely right, because the core and shell temperature are managed by a middleman, and that is the blood. The blood, as I mentioned before, is a key player in ensuring that heat is distributed properly between the core and shell temperatures. So if the core temperature gets too high, heat is transferred into the blood, veins dilate, heat goes out of the shell. If the core temperature is too low, heat is conserved in the blood, veins constrict, and essentially veins constrict in the peripheries, but they dilate in the core so that the core receives more heat. And your vital organs such as your lungs, your heart, your gastrointestinal system still has the adequate amount of heat to be remaining functional. Now, before we look at what happens when your body temperature becomes too low, let's firstly look at the upper limit. So usually when you get a fever, if you're an adult, your temperature doesn't usually go above, or doesn't go too far above, around 38 to 38.5 degrees Celsius. However, if you're a child or a baby, then it's likely that your fever temperature will probably go above 39 degrees Celsius up to 41 degrees Celsius. And the reason for this is that children and babies are not as, they don't have the same advanced temperature controlling mechanisms as adults do. And the reason for this is it goes back to the core and shell temperature. Babies especially have a very large core to shell ratio, in that the shell is quite large compared to the core. And that essentially means is that they lose a lot of heat. And that's one of the main reasons why we put beanies on babies, because a baby's head is 25% of its total surface area, and that means they lose a lot of heat from their head. So essentially this ratio is why there's more temperature fluctuations in babies and children. And if babies and children have fevers, that's why they get a higher temperature reading usually. But if we take this out for just this example, and we just consider an adult, 38 to 38.5 degrees is usually the fever temperature, and that occurs because bacteria aren't able to proliferate at high temperatures at the same rate as they do at lower temperatures. So the body basically tries to increase its own temperature so that bacteria die. If the body reaches 41 degrees Celsius in an adult, then the alarm bells start ringing, because 41 degrees Celsius is basically where convulsions start to occur, so febrile seizures start to occur, and that means that the proteins start to denature, and essentially the body starts to shut down. Between 36.5 and 41 degrees, there's an interesting phenomena that occurs, and that phenomena is called the temperature effect. And the temperature effect is essentially when proteins are operating, they generate heat, right? And an increasing temperature increases the function of a protein, because if you're in a hotter environment, the proteins are able to work at a more efficient rate. And essentially a positive feedback loop is established. So when proteins work, they generate heat, so there's more, the temperature increases, and this increased heat means that the proteins are able to work harder, and that further increases the temperature, which means that the proteins work harder, and then that increases temperature. So that means that the temperature essentially increases infinitely until this 41 degrees mark. And so you might see that proteins work more efficiently until that mark, but once they pass that mark, the proteins have become so warmed up that they start to lose their structure. Essentially, the bonds between the proteins start to break up. And that's when you start to experience convulsions at 41 degrees. And the definitive limit for body temperature is 43 degrees Celsius. And when you reach 43 degrees Celsius, basically all of your proteins have denatured, and that's when death results, because your control systems that try to control temperature within the body have become exhausted and they can't work anymore. One, because the temperatures become so high, but two, because these control systems are basically proteins, and if proteins have become denatured, then the very building blocks of the control systems aren't able to work properly. So that's why you essentially your body fails in that sense. So one thing you might have noticed by looking at the scale is that your body isn't able to tolerate high temperatures to the same extent that it is able to tolerate low temperatures. And the reason for this is that even though proteins denature at high temperatures, proteins don't denature at low temperatures. They essentially just slow down to the extent to which they become non-functional. And if a person undergoes hypothermia, the proteins and their body tissue is much more salvageable to a certain extent than if they undergo hyperthermia. So let's have a look at these lower temperatures. So starting off from 36.5 to 37.5 degrees, if you go down to 33 degrees, I'll spread this out a little bit more. If you go down to 33 degrees, an interesting phenomena occurs. When reaching 33 degrees, your body goes into a state of, it becomes essentially comfortable, and between 36.5 and 37.5, you start to shiver. Between 36.5 and 33 degrees, you start to shiver. However, after 33 degrees, your control systems stop, and the person essentially becomes comfortable, in inverted commas, of their surroundings. And if you are tending to a patient that is undergoing hypothermia, and suddenly they go from being shivering to, feeling quite good, then that can be quite a bad sign, because it means that their control systems have failed, and they're essentially feeling comfortable in this scenario where their body temperature becomes so low that they can't control their temperature. And although, on the outside it might seem as a good sign, a patient becoming comfortable is quite negative. Now, colder temperatures usually have an effect on the heart, as opposed to warmer temperatures that have a systemic effect. And if your body temperature goes from 33 to 30 degrees Celsius, then you start experiencing a lot of arrhythmias. Namely the most common arrhythmia, which is atrial fibrillation. And atrial fibrillation can have a lot of negative effects, because not only is it an arrhythmia, which is already a negative thing, it can cause a stasis of blood within the heart. And as we all know, if blood stops flowing, then it clots. And if your blood is already cold, if it's already not flowing to a lot of the organs in the extremities, then in addition, if there's a clot, then you don't have a lot of hope or chance of surviving that, because your blood will be so slow and so viscous that it's unable to provide parts of the body with appropriate nutrients and oxygen. Now, the final limit for life usually occurs when your body temperature reaches on the lower end of 28 degrees Celsius. And that's essentially when ventricular fibrillation or ventricular arrhythmias occur. And ventricular arrhythmias are especially quite dangerous, because the ventricles of your heart are responsible for either pumping blood to your lungs, in the sense of your right ventricle, or to the rest of your body, which is your left ventricle. And if there's some sort of electrical or organic issue in terms of your ventricles, then essentially you aren't able to pump blood to the rest of the body. And as I mentioned before, Fibrillation and arrhythmias cause stasis, which means that blood clots and therefore your body isn't able to receive any substantial amount of proper nutrition. And that means that you essentially go into a comatose state, and death isn't very far after that. So a quick review of what I've talked about today. So firstly, your normal body temperature, so your normal range for body temperature is between 36.5 and 37.5 degrees Celsius, and that's mediated by your core and shell temperature, which is connected to each other by your blood. Usually adults experience a fever between 38 degrees Celsius and 38.5, but that can increase in children and babies to 39 to 41 degrees. And that's why something I forgot to mention is you do experience febrile convulsions in children, usually until the age of 4. But if it does happen after the age of 4, then that is a cause for concern. If the temperature goes above 41 degrees, then proteins start to denature and you even see convulsions in adults, and 43 degrees is the limit for life. Between 36.5 and 33 degrees, you start to shiver, and under 33 degrees, you essentially become comfortable to the surroundings, which is a very negative sign in terms of temperature regulation. Under 30 degrees, you experience arrhythmias, and until 28 degrees, you experience ventricular fibrillation, which is essentially a very short period of time before you experience death. So lastly, I just want to enhance one more time that your body can experience lower temperatures to a much greater extent than higher temperatures. So I hope that's all made sense today. Thank you very much for watching.